Hello everyone, let's upgrade the endgame manager script with the singleton pattern. A singleton pattern means that can be only one object of the same type in the whole game. That means we should have only one endgame manager in the entire game. This is very useful for static classes since we need to be careful about performance. At this point we have one scene, let's call it level 1. Now duplicate it and call it level 2. When we go from one scene to another, all objects from the previous scene are destroyed. For example, we go from level 1 to level 2, all objects from level 1 are destroyed, and Unity loads new objects that we have in level 2. Connecting all scenes together, we get a game. When a player plays the game multiple times, he can start it on different levels. The idea is to somehow preserve the manager from the level where the player started. By default, we have some objects in every scene, and every scene has the endgame manager object. So let's go to the endgame manager script. In the awake function, first we check if the instance is null. Then set the instance to this class. Then we use the don't destroy on load function. We don't want to destroy this game object. Just to show you, I will run the game. Click on the pause button and you can see that the endgame manager is placed in another scene called don't destroy on load. Let's say we started the game on the first level. We go to level 2. All objects except the endgame manager will be destroyed because of the don't destroy on load function. This manager will go to the level 2. But now we have two game managers, one from the first level and another that was by default in the second level. We need to destroy one from the second level. In the script, use else, which means that the end manager instance is not null. Then destroy this game object. So the game manager from level 2 will run the awake function, and the instance of end manager will not be null because it will detect it from the manager that came from level 1. So in our example, the manager from level 2 will run this part of the code and destroy itself. And that's it, we created a singleton pattern. In the next lectures, we will learn how to switch between scenes. See you there! Hello everyone, let's see how we can change scenes using buttons. To organize the hierarchy, let's create a new empty game object. Call it controllers. We can place the panel controller under it. Now let's create a new object and call it button controller. Then create a new C# script. I will call it also button controller. Add the script to the object and open it. First, to change scenes, we need to use the scene management namespace. We can delete default functions. Now let's create a public function load level string. It takes one string parameter. I will call it level name. To load another scene, we use scene manager.load scene. And then we will paste the string, which will be the name of the level. We can also load new scenes using integers and build index. So let's create a public load level int function that takes one int parameter level index. Make sure that functions are public. Here we also use scene manager.load, but we paste the integer level index. So where to find build indexes for levels? Go to Unity, File, and Build Settings. Here you can find scenes that will be included in the game. Our level 1 is included, and here you can see the build index, it's 0. We can go to the scenes folder and add level 2 to the build. You can see that his index is 1. So to load level by index, we would paste one of these numbers. Great. Now let's create buttons so we can call the functions we made. First, let's select the panel and increase alpha so we can see what we are doing. Then right-click on the Win screen and create a button. I will call it Home button. We can delete the text. Let's change the source image for the button. Use the Home icon sprite. Click on the Set Native Size button. Let's change the anchor preset. Choose Center Bottom. We can move it a bit down. This looks fine for now. You can see that the button has on-click event. This is called when we click on the button. Let's add a new event. Idea is to call functions from the button controller. So let's drag the button controller. Then we choose a function to call. From the button controller script, let's use the load level string function. Now we can write the name of the scene we want to load. Later, this button will lead to the main level selector, which we don't have now, so use level 2. You could also use the function load level int and write the build index. But in this project, we will mostly use the string option. We will use loading with the build index just to restart the level. I just wanted to show you both options. Next, let's enable lose screen and create 2 buttons. First will also be Home button. Change the position. Duplicate it and call this button Retry. Change the icon. Now we can add the on-click event to the buttons. To the Home button, let's add load level string function. For now, leave it empty. We will change this later. Use the same function for the Retry button. Here you can write the name of the current scene, but you don't want to write strings for every retry button in every level. It's a lot of work. So let's go to the button controller script. Create a public restart level function. We use scene manager.load scene, and then we use the build index of the currently active scene. So write scene manager.getActive scene (build index). This will restart any level in which the player is. So for the retry button, use the restart level function. We are not done, but let's try it to see potential bugs. Disable the screens and change the alpha value to 0. Let's try to win. I will speed up time a bit. You can see the win screen and the button. Press it and we should be in level 2. It works, nice. Let's exit the play mode and start it again. Now let's try to destroy the player. We get the lose screen. Let's restart the level. I will click on the pause button to show you one problem. You can see that the variable game over is still true even when we restarted the level. It's because the endgame manager is a static singleton and all variables kept their values. So now, if we continue playing and get to the end of the level, we will still get the wrong screen. Luckily, there is a simple solution to this. Go to the player stats script. In the start function, we set the value to false. Now every time we load levels, the variable is set to false. We can do one more thing in the win condition script. In the update function, we can check if the game over variable is true. Then just return and don't execute the code below. That means that the timer will stop when the player is destroyed. Let's try it now. Destroy the player. Restart the level. Try to win it after the restart. And we get the win screen. Now everything works. Of course, we don't want an instant transition between levels, we need some kind of fading effect, which we create in the next lecture. See you there! Hi everyone! Let's create a nice fade effect between loading scenes. I will create this effect on a separate canvas and also with the singleton pattern. So let's create a new canvas and call it canvas fader. Change it to scale with screen size. We can also change the reference resolution. Then let's create an image. I will call it background. For the source image, we can use the square, then stretch it. And change color to black. To make sure that this black image is visible in front of other UI elements from another canvas, we need to increase the sort order of this canvas. Then select the image and add the canvas group component. Idea is to change the alpha value to create the fade effect. Of course, here we don't have buttons and other interactable elements, so we can uncheck the interactable and raycast options. To change the alpha value, we could use animation, but for mobile devices, animating UI elements is expensive and not good for performance. So the better option is to use scripts and change the value through code. Let's create a new C# script. I will call it fade canvas. Add the script to the canvas fader and open it. First, let's create a public static fade canvas instance. Then let's create a singleton pattern, just as we did for the game manager. This is a good practice to repeat some things. Now we need variables. First we need a canvas group. Then we need a float change value, float wait time, and bool fade started. That's all variables we need. We can delete the update function. To create fade effects, we will use coroutines. So let's create the IEnumerator fade in function. This function will turn the black screen transparent. First, let's set the fade started to false. This variable will be true only when we use the fade out effect. Then we use the while loop. while the alpha value is greater than 0, we need to decrease it. So let's decrease the alpha value with the change value variable. Then we need to set the speed of change. After each change, let's use the wait for seconds function and the wait time variable. We can call this function in the start. Let's see what we made. In Unity, use the canvas group from the background image. The change value variable needs to be a small number. I will set it to 0.04. The wait time can be 0.01. Let's try it. You can see that we have a nice fade-in effect. If you want to make it longer, we can decrease the change value or increase wait time. You will see that the effect lasts longer, maybe too long, so I will make it shorter. Back to the script. Now let's create the opposite effect. The image should go from transparent to black. Create a new IEnumerator function, fadeOutString, which takes one string parameter. Now the fadeStarted variable will become true. Now, while the alpha value is less than 1, we need to increase it. Then we also use wait for seconds. We will exit this loop when the alpha is 1 and the image is black. Then we need to load level. Let's include the scene management namespace. Then we can use load scene and pass the string level name. After that, we again start the fade-in effect in the new scene and the background image is going back to transparent. We can add some wait time between loading and fading effect. Remember that this object is a static singleton, so it will not be destroyed when changing scenes. To make sure we don't get multiple calls, we can check if fade started. If that is true, then use yield break. Now let's create a public function faderLoadString. Here we will start the fade out effect. Then go to the button controller that we made in the previous lecture. Remember, when we press buttons, this function is called to load a new level. Instead of loading scenes directly, let's use the function from the fade canvas. In Unity, just check that your home button is using the function from the button controller. We did this in the previous lecture. Before we try it, let's duplicate this level 1 so we have the same components. Delete old level 2, rename duplicate to level 2. Later, when we create all the necessary objects that need to be in every scene, then we will have a template scene and prefabs from which all scenes can be created. For now, we copy-paste scenes to test them. Let's try. We should see the fade-in effect. Try to pass the level. Then we should see the fade-out effect and then fade in again. Nice, it works. Now I have 1-minute challenge for you. Try to create a fade-out function that will take one int parameter instead of string. The solution is quite simple. We can just copy-paste code and set that load scene takes level index. We also need to create a public function to call the integer version. In the button controller script, we use this function to restart the level. Again, instead of calling it directly, let's use the function from the fader. We don't use this function anywhere, but let's change it. Maybe you will use it somewhere in your game. It needs to use the integer version from the fader. Let's try to restart the level. We can see the effects. And that's all for this lesson. In the next lecture, we create a loading screen. Hi everyone, in this lecture we create a loading screen. Let's right-click on the canvas fader and create an image. I will call it loading background. We need to stretch it. Then change the color. Now we need to find the health bar because we will copy-paste some elements. Paste the health bar and make it a child object of the canvas fader. Let's delete some extra elements. We don't need the icon holder. Now we can place the loading bar in the middle of the screen. Let's increase the size a bit. It needs to be a child object of the loading background. This looks fine. Let's go to the fader script. First, let's include the UI namespace. Then we need one game object variable called loading screen. Then we need one image, the loading bar. Now find the fadeout function. We can comment out this code because we will use the async operation to load levels. The async operation gives us the option to load level as a background process and we can keep tracking the progress. So, through the async operation, we get access to the progress which goes from 0 to 1. When the level is fully loaded, the progress is not actually 1, it's 0.9. This 0.1 difference is reserved for the bool variable allow scene activation. We can control that variable and if we set it to false, even if the next level is fully loaded in the background, the progress value can't get over 0.9 and we can't go to the next level. When we set this variable to true and the level is fully loaded, then the value is 1 and we can go to a new level. We have another important bool variable is done. This variable is true when the progress bar is 1, which means fully loaded level with allowed scene activation, and it's false in any other case. So we will use these variables to create a loading bar. First, we create an async operation variable that will get a value through scenemanager.loadSceneAsync. This will load a new scene in the background. Then we set scene activation to false so we have control. We need to activate the loading screen. And we can set the loading bar fill amount to 0. Now we use while loop. While the async operation is done is equal to false, which means that the level is not fully loaded or activation is set to false, we set the fill amount to async operation progress. Since the value goes to 0.9, we need to divide it by 0.9. Here we don't need to use wait for seconds, we can just return null. Between those lines of code, we can check if the progress is 0.9. Again, that means that the level is fully loaded in the background. Then we allow scene activation. At that moment, the isDone variable will become true and we exit the while loop. We can delete this line of code. Now we can copy the code. In another fadeOut function, paste the code. Just replace the level name with the level index. We need to do one more thing. In the fadeIn function, we need to deactivate the loading screen. Now go back to Unity. Before we connect objects with the script, let's rename them so we don't confuse them with the real health bar. Then use the loading background as the loading screen object. For the loading bar image, let's use loading fill. Let's try it. Win this level. Then go to the next. Notice that because the level is too small and we are testing on PC, the loading is too fast and we can't see it. But on a mobile device you would see progress on the loading bar. One more trick: if the fader canvas is covering your view in the scene, you can hide it with this button. And that's all for this lecture. See you in the next one. Hello everyone, this is Mario from the future. Later in the course I noticed one bug with the fading system. It's very specific, but we need to address it and fix it with just 2 lines of code. If you see something in Unity or in the code that we didn't do yet, don't worry, this is because I recorded this video after a few episodes and decided to place it here in the course. I will quickly show you the bug. Here I placed 2 debug logs, one for fadeIn and one for fadeOut effect. Select the canvas fader. Now I will just make the fade effect longer. It will be easier to replicate the bug. Also, I will use scenes that we make in the future. It will be easier to understand. I have a level selection scene. This button starts the fadeOut effect and leads to a new level. At first you can see everything works. But there is a case if I press the button and activate the fadeOut function while the fadeIn is still running, then 2 while loops will fight each other. Let's press the button while the fadeIn effect is still active. You can see it in the console. At the same time we are decreasing and increasing the alpha value. Because of this we can't go to the next level, because the screen will never turn black. We can fix it in several ways. My way is to go to the fadeIn function. In the while loop, we can check if the fade started variable is true. That means we activated the fadeOut. Then break and exit from the loop. That is all we need to do. Now if I press the button, the fadeIn effect will stop and the fadeOut effect will take over. If you want different behavior, for example that fadeIn effect must finish, then you can check in the fadeOut function for the alpha value. If it's not 0, then break and exit this function. Now we can press the button, but nothing will happen until the fadeIn is finished. It's up to you to choose the best option for your game. Thanks for watching and see you in the next lecture. Hi everyone, in this lecture we go through the process of creating font assets for our TextMesh Pro text. I will drag the fonts folder from the other screen. You can find the link to the download page in the resource folder. You can use the same font or any other that you wish. Now let's right click on the canvas and create text. I will quickly rename it. You can see that this is the default font. We can try to change it directly, but nothing will happen. We need to create a font asset to replace the font. Go to Window, Text Mesh Pro, and open Font Asset Creator. As a source font file, use the font you want. You can see some settings, we can leave default ones. Maybe the most important setting is render mode. For this font, the default setting is good. If you use pixelated fonts, raster mode is better. So it depends on the font we use. You can try different options. Then click on the Generate Font Atlas button. Then we can save the font asset. Now drag the asset we created to the font asset field. And you can see the new font. You can play with some settings to explore the Text Mesh Pro package. We can also replace the font that we use for the win and lose screens. Delete the test text. After you enable all objects and set canvas alpha to 1, you can see the result. Nice, that is all for this lecture. Hi everyone, let's create a scoring system in which a player gets points every time he destroys enemies. We will show the score in the upper right corner, so it needs to go in the safe area. Right-click on the safe area and create text. Let's change the anchor preset to the upper right corner. Hold Alt and Shift and click. Let's change the position a bit. We can expand the text area a little bit. We can change the font. This font asset we created in the previous lecture. Let's change the alignment. I will choose the middle, but maybe you can leave the left alignment. This also goes to the middle. Now let's write a score of 1000. Notice how the text goes in the next line. To prevent that, we need to disable wrapping. Let's expand the text area a bit more. Of course, you can change the font size if you want. I will leave it as it is. Let's go to the Endgame Manager script. Since we will use the Text Mesh Pro package components in the script, we need to include the TM Pro namespace. Then let's create a text component variable. Now we need a reference for this text. Let's create a public function to register the score text. Now we can go to Unity to create a new C# script. I will call it score registration. Add the script to the text we created before. We don't need the update function, we need the TM Pro namespace. In the start, let's create a text component. Since this script is on the object that has a text component, we can use getComponent. Then we can register the text to the Endgame Manager. It's a good idea to set the text value to default one with a 0 score. Go back to the Endgame Manager script. Now we can create an int variable score. Let's create a function that will increase the score and update the text. it needs to take one int parameter. First, we increase the score. Then we update the text. Since the score is an integer, we need to convert it to a string. Great. The idea is to call this function every time the enemy is destroyed. Let's go to the enemy script. In the enemy script, in the death sequence function, which is called every time enemy dies, we call the update score text. Of course, we need to pass one variable to the function. So let's create one int variable score value. This value will increase the score. Note this is all done in the parent enemy class. We need to update child classes. Let's start with the Meteor script. When we override the death sequence, we need to call the base death sequence. This will call everything from the base class. Let's do the same for the purple and green enemies. Go to Unity. In the prefabs folder, select enemy prefabs and choose the score value for each of them. I will go with 10 for all of them, but you can choose different values. Let's try it. As we destroy enemies, the score increases by 10. Great. Of course, I would like to show the score and the high score on the win or lose screens. We also need to reset the score after that. Go to the endgame manager script. If you remember, we have the win and lose functions. Here I mentioned we need to do something about the score. We need to show the score, check for high score for this level and then reset the score. To do all of that, we need to know something about saving and loading data, which we learn in the next lectures. See you there! Hello everyone, this is a quick video explaining the player prefs syntax. Using simple examples, we will see how to save and load basic data. I created one example script, you don't need to write it, just follow and try to remember the syntax. Okay. Here I have 3 variables that I want to save. Notice that I used 3 data types that we can save with player prefs, and those are integer, float and string. So to save data, we use player prefs.set and then choose the type. In the first example, we use setInt. In parentheses, first we write the string key, which will hold the value we save. You can name it as you wish. I chose int key. Then we write the value to save, in this case example int. The same logic applies when saving float and string values. So how to load saved values? We will use these keys. I also created variables in which we will load the saved values. To load values we use playerprefs.get. Of course, we can get integer, float or string. In parentheses, we write the key to load values. So the int key will load the example int value we saved. Just make sure that you correctly write the key. If you miss some letters or something, this will not work. The second part in parentheses is optional. It determines the default value if we haven't previously stored anything in this key. It can be any value you want. I just set it to 0 and nothing. To delete saved values, we use the delete key function. In the parentheses, we write the string key that we need to delete. Also, there is an option to delete all saved data with the delete all function. Of course, when testing, deleting all saved data from the code can be unpractical, so in Unity, we can go to Edit, and here we have the clear all player prefs command. That is all for this lecture. Now that we know the syntax, we can create a high score system. Hello everyone! Now that we know the player pref syntax, we can create a save and load system. The goal of this lecture is to save the score for each level and determine a high score. Let's go to the endgame manager script. We need to create one function that will save the score and update the high score if needed. So create the score set function. Let's use player prefs set int. The key will be score combined with the name of the current scene. In that way, every level will have a different key, and that is what we want because every level has its own score. The value we save is, of course, score. Then let's create one int variable, high score. We use the getInt value. The key will be high score combined with the scene name. The default value needs to be 0. Then we check if the score is greater than the high score. If that is true, then the score is a new high score and we can save it. Use the high score key. And save the score value for that key. The last thing we need is to reset the score. Now we need to call this function in the win and lose functions. Just make sure you call it before we activate screens. This is really important for the next step. This is all we need to do in the game manager. In Unity, I want to display the score and the high score on the win and lose screens. Let's select the panel and increase alpha to 1 so we can see what we are doing. Enable the win screen. We need to organize this screen and add some text components. Let's change the color and set the anchor to the top middle. We can add extra effects to this text. Enable the underlay. I will use white color with smaller opacity. Now you can play with the settings and change the offset. I think this looks nice. Now we need text for score and high score. Duplicate this text. Rename it. We need to change the anchors to the middle. Adjust the text area a bit. Of course, we need a smaller font. Change the text so we have a better preview. The alignment needs to be left. We can also disable wrapping if needed. Let's move it down. Then duplicate it. This will be the score. Change the color and rename it. Your mini challenge is to do the same for the lose screen. This is the final result. As you can see, I changed the color for this screen. Let's disable them and return alpha to 0. Let's create a new C# script that will be responsible for score display on the win and lose screens. and open it. Delete default functions. We need to include TM Pro and Scene Management namespaces. Then create two text variables, one for the score and one for the high score. Then we use the onEnable function. This means the code will run every time we enable the object, and this script will go on the win and lose screen objects. First, we create a local variable score in which we load the score value. Use the getInt function. The safest way to write the key correctly is to copy-paste it. Go to the Endgame Manager and copy the score key. The default value can be 0. Now let's update the text with that variable. Do the same for the high score, just make sure you copy the correct key. That's all we need to code. Let's go to Unity. Add the script to the win and lose screens. Now we need to set up a reference for the text variables. Use the high score and score text that we created earlier. And that's it, we can try it. You can see the score and the high score. Now it's 10. Let's play it again. You can see updated values. Maybe the screens are too small, so feel free to change the dimensions. See you in the next video. Hi everyone, in this lecture we prepare scenes so that we can easily create an opening scene, a level selection scene and new levels. This is just preparation, nothing special, but we need to do that so we can be faster and more efficient in the next lectures. First, we need to create prefabs. Select the managers, spawners and controllers. We can select the win condition, canvas and the player. Drag them into the prefabs folder. Save the scene with Ctrl S. Go to the scenes folder. We are in level 1, so duplicate it. Rename it to start screen and open it. This will be the first scene the player sees when entering the game. We can delete some objects. Let's delete spawners, panel controller, win condition, everything that's connected with the virtual camera, then the player and virtual camera. Let's also remove the Cinemachine Brain component from the main camera. I will use one text from the canvas. This will be the win text. To use it, we need to unpack the prefab. Now drag the text under the safe area. We can delete the panel. We can also delete the score and health bar. Let's rename the text. This will be name of the game. Expand the text area. Increase the font and change the anchor preset to top middle. This is a good position. Since we are not using Cinemachine and virtual cameras, let's select the main camera and set the size to 5. Let's see how it looks. Not bad. Let's change the color of the text. The vertex color needs to be white. Now enable color gradient. I will use a horizontal gradient. The first color will be yellow. The second color will be orange. Great. Let's save the scene and duplicate it. Call the new scene level selection and open it. I will just change the text so we can recognize it. This is a level selection. Of course, we will polish and add features to these scenes in the next lectures. Remember, this is just a small preparation. Save the scene and open the build settings. Now let's add new scenes to the build. Change the order so that the start scene is the first one, then level selection, and then levels. Okay, that's all for now. In the next lecture, we finish the start scene. Hi everyone! In this lecture, we implement the tap to play mechanics in the start scene. So make sure you open the start scene, then right-click on the canvas and create an image. Call it tap to play trigger. We need to stretch it. Then set the alpha value to 0. Now let's add the event trigger component. We use it to create a new event type. You can see some events. For example, pointer down is when we press on the screen, more precisely on the transparent image we created. Of course, pointer up is when we lift the finger. Let's use it. Create a new event. Now we need to drag the button controller object. We will use the load level string function. Then load the level selection level. Great, when we touch the screen and lift the finger, we should trigger the event. Let's try it. Click anywhere on the screen. It works. Now let's add some visual elements to this scene to make it look better. In the safe area, let's create a new text. Change the anchor to the bottom middle. Place it like this. We can change the font. Expand the text area. Change the alignment. Text input should be tap to play. Change the font size. To make it more interesting, I want to create this blinking effect. We should create a script, but I will use animation for this text. Important, as I said, animating UI elements is performance expensive and you should avoid that usually. But for this start scene that has very few elements and we are only in it a couple of seconds, we can get away with animating one element. So let's create animation. I will call it tap animation. Hit the record button and animate the alpha value. Let's see the preview. It's a bit too fast. Let's set samples to 30. This looks fine. Let's try it. Tap on the screen. Great. We can also add the spaceship sprite to this level. Set the position to 0, 0 and increase the order in layer. Decrease the size a bit. And we are done. See you in the next lecture. Hello everyone, in this lecture we create UI elements for level selection. As you can see, we built a nice scrolling system. To start, let's make sure we open the level selection level. Expand the canvas, and under the safe area create one button. Let's change the source image. Use the level icon sprite. Set a native size. Now let's change text settings. The color needs to be white. Write any number, it doesn't matter, they will be automatically assigned. We can increase the font size. I will change the text area a bit. Great. We can change the font. This font is a bit bigger. You can maybe disable wrapping or just decrease the size a bit. This is maybe too small, I will set it to 39. We can easily write 3-digit numbers with this font size. Now select the button. We need to add on-click event. The button needs to use button controller. And we need the load level string function. This button will lead to level 1. This is just a template button. Now we can create the scroll area. Right-click on the safe area and create an empty game object. I will call it level base. Now let's change the dimensions. We are setting scroll area boundaries. Then right-click on the level base and create an image. I will call it viewport background. Stretch it. For the source image, use the large panel sprite. Make sure that the image type is sliced. I will just change the color. Now right-click on the viewport and create an empty game object. Call it grid content. Set anchor presets to the top middle. Now let's add the grid layout group component. This component will arrange buttons into a grid. We need one more component, it's called content size fitter. It will expand the dimensions of this object as we add buttons. Set horizontal and vertical fit to preferred size. Let's drag the button under the grid content. Now we can duplicate the button. And you can notice that because of the grid layout component, they are arranged in a grid. Let's change some settings. Cell size can be 200. We can set a fixed column number. Let's use 3. We can add spacing between buttons. and some padding at the top and bottom. Also, let's set the alignment to the upper center. As you can see, we can easily create a grid of buttons. Let's add more buttons. Notice one problem: the buttons are visible outside of the background. We have an easy fix. Select the viewport background, then add the rect mask to the component. This looks better, we just need to adjust the padding. Notice how buttons overlay the edge. Set bottom and top padding to 15. Great. Finally, we can select the level base object and add the scroll rect component. For the content, let's use the grid content. We can disable scrolling in the horizontal direction, we only need vertical. For the viewport, use the viewport background object. Let's try it. It looks nice, and we can scroll up and down. Of course, you can change the settings and behavior of the scrolling. I like to set this deceleration rate to 0. Now we have UI setup for the level selection. In the next lecture, we add functionality and level unlocking. See you there! Hello everyone! In this lecture, we create a fully functional level selection and unlocking system. When the player wins the first level, the second will unlock, and so on. We need to go to the End Game Manager script. As you can see, I mentioned before that in the win game function we need to unlock the next level. But first, let's create one variable. This will be a public string level unlock. We don't want to ever change this string, so let's hide it in the inspector. This string will be used as a key for saving and loading data. When we pass a level, we need to get the index number of the next one. So let's create an integer next level variable. The value will be the current level build index increased by 1. Then we check if that next level index is greater than the value we store in the level unlock key. Set the default value to 0. If that is true, then we save the next level index to the level unlock key. The key will have the highest unlocked level index. That is all we need to code in the game manager. In Unity, create a new C# script. I will call it button icons. Add this script to the level base object and open it. We need to use the UI namespace. Then let's create some variables. We need an array of buttons. Then we need 2 sprites for buttons, one for unlocked and one for locked buttons. We also need the number of the first level build index. What is that number? If you take a look at the build settings, you can see that the first level in our case starts with the build index 2. Okay, now we need the awake function. It's called only once before the start function. First we need to get an index of the last unlocked level. So int unlocked level will get a value from the string key we made in the endgame manager. It's important to set the default value to the first level build index. Then let's create a for loop to go through the array of buttons. For every button, we check if the I plus the first level index is less or equal to the unlocked level variable. I starts from 0, so we need to add that first level index value. Remember that unlocked level variable is the index of the highest unlocked level. That means that every level with a lower index needs to be unlocked. So first we set the button with index I to interactable, then set the sprite of the button to unlocked icon. Now we need access to the text. We need to include the tmpro namespace, create a text variable, then use the button and get component in children function. Remember that the text is a child object of the button. Then we need to set the text value. After that, just make sure that the text is enabled. In other cases, levels are locked, so we need to set the button interactable variable to false. Set the sprite to the locked icon. Also, we need to disable the text component. That is all we need to code. Go to Unity, assign unlocked and locked icons, let's double check the first level build index. The index of the first level is 2. Then add buttons to the array. At this point, every button will lead to level 1. We need to select buttons one by one and change values. This button will lead to level 2, the next one to level 3, and so on. This is the only thing we need to do manually. It's a 5 to 10 minute job, depending on the number of buttons. There are ways how to do this automatically with scripts, but that is beyond the scope of this course. For now, you don't need to change all buttons, we only need buttons for 2 or 3 levels for testing. Before we test it, let's go to the first level. Here we need to adjust some buttons. The home button on the win and lose screens needs to lead to the level selection. Now we can test it. We start the game, go to the level selection. Since this is the first time we play, only the first level is unlocked and others are locked. Let's try to pass the first level. Now we can see that level 2 has been unlocked. Great. In the next lecture, I will show you how to easily create new levels. Then you can connect all buttons with created levels. See you there! Hello everyone, in this lecture I will show you how to easily create new levels. We can delete level 2, it's an old copy. For now, we have all that we need in level 1. You can see all managers, controllers and other prefabs in this level. Now duplicate this scene and call it a template scene. Open it. This scene contains all the necessary objects to create a basic functional level. Now we can duplicate the template scene. This can be level 2. Open it. Now it's easy to add or remove prefabs. For example, we can delete the meteor spawner in this level. We can also change numbers, for example the spawn time. If you need different enemies, you can replace prefabs. Select the win condition and update the spawner array. We don't have meteor spawner, so delete the empty field. We can also change the win timer. Now we have a completely different level. Let's create level 3. Duplicate the template scene. In this level, you can set variables to different values. This is just an example, so I will set them randomly, with no testing. Of course, if you have some other spawner prefabs or anything else for this level, you can just drag them into the scene. Just make sure that you update the build settings. And that is how you can easily create levels. For testing, just create 2 or 3 levels. Don't create too much, because we will need to update the template scene with new content later in the course. I just wanted to show you the process, but it needs to be done when you have all things connected between objects. Later we create ads and power-ups that need to be connected to the player. Keep that in mind and see you in the next lecture. Hi everyone, in this lecture, for testing purposes, we will build the game on our Android device. We have enough content to try the game and see how it feels on a mobile device. Before we start, make sure that you have the Android module installed for the Unity version you use. Then go to Build Settings. And make sure you use the Android platform. We did all of that at the start of the course, but I just wanted to repeat it in case you missed something. Now go to Player Settings. Here you can find some options like company and game name, version and icons. For testing, we don't need to change them, maybe just the company name. Let's go to the resolution and presentation. By default, auto rotation is selected with all orientations. Let's limit this to portrait mode. Then go to Other Settings. For the publishing version, we will need to change more settings, but for testing, let's just disable this bundle identifier override. And for the target API level, choose the one with the highest number. Now we need to connect our mobile device to our PC. On a mobile device, we need to enable debug mode. Go to Settings. The next procedure can be a bit different for you. It depends on the device, but usually we need to find About Phone. Then open the software information. Now tap a few times on the build number. You should see a pop-up that developer mode has been turned on. Now go back to Settings. Scroll down and you should see developer option. Make sure that it's on. Then find USB debugging. Enable it and that should be it. In Unity, you can press refresh and you should see your device. If you don't see it, reconnect it and make sure that you have file sharing via USB turned on. Then we can press Build and Run. Create a new folder for the build. The file name will be Space Shooter. Click Save and wait a few moments. When you do it the first time, it takes a bit longer. The build should appear on your PC and on your mobile device. Also, it should automatically start the game on your mobile device. Now you can test the game and get a better feeling. As you can see, everything works just as it should. Nice. Also, when you make some changes in Unity and you want to test the updated version, then enable development build and hit patch and run. Great. Now you know how to test your game on a mobile device. See you in the next lecture. Hi everyone, in this lecture, for testing purposes, we will build the game on our iOS device. We have enough content to try the game and see how it feels on a mobile device. Notice that I'm using Windows, but to build the game on iOS, we will need a Mac computer later in the process. Before we start, make sure that you have the iOS module installed for the Unity version you use. Then go to Build Settings and make sure you use the iOS platform. Now go to Player Settings. Here you can find some options like company and game name, version and icons. For testing, we don't need to change them, maybe just the company name. And remove spaces from the product name. Let's go to the resolution and presentation. By default, auto rotation is selected with all orientations. Let's limit this to portrait mode. Then go to other settings. For the publishing version, we will need to change more settings, but for testing, let's just disable this bundle identifier override. Go back to build settings. Now we need to create a build. Create a new folder and then start the process. It may take some time to finish. Here is the folder with all data. Now we need to transfer this folder to a Mac computer. Let me just switch to Mac. As you can see, here I have the build folder on Mac. Inside the folder, you should find the Xcode project. If you don't have the Xcode application, just go to the App Store. Search for Xcode and install it. It's completely free, but it's only available on Mac. Open the Xcode project. Select the Unity icon and you will see some settings. Most of them will be from Unity. If something is missing, you can quickly add it. Again, this is just for a test build, so you don't need to go into details. The important part is to go to the signing section. Here we need to enable automatic signing. Now we need to add a team account, which can be just you. To create it, go to Xcode, Preferences, Accounts, and click on the plus button. Use your Apple ID to sign in. After that, you need to add a development certificate. Go to Manage Certificates, click on the plus button, and add the Apple Development Certificate. Go back to the signing section. Now we can choose a team account that we made. Now you need to connect your iPhone to your Mac. On your phone, go to Settings and find Privacy and Security. At the bottom, you should see Developer Mode. Sometimes, to see this option, the Xcode must be open, otherwise you will not see it. Let's enable Developer Mode. Your phone will restart. After that, on Mac, make sure you select your iPhone. To start building the game, click on the play button. This will take some time. If you get some error, try to open your Unity project on Windows with a different version. Actually, I got some weird error that I couldn't resolve with all possible fixes. It turns out it's because of the Unity 22 version. Something is wrong, I'm sure they will fix it in the future. Maybe you will not have errors with the latest version. But I needed to open my project on Windows in Unity 21 version, build it and transfer files on Mac and repeat this whole process. Then everything was fine, with no errors. If you get this pop-up message, just type the password you used to sign in to your Mac and click on Always Allow. When the build is finished, you will see this message. The game couldn't open on your iPhone because we need to trust the developer. On the phone, go to Settings, General, Device Management. Here you will see the developer app. Open it. Then you need to trust the developer. Now you can find the game and test it. Let's play it a bit to see if everything works. Nice, it's all good. This is how you test your game on your iPhone. Have a nice day and see you in the next lecture. Hello everyone, in this lecture we create a scriptable object that will help us spawn power-ups. Scriptable object is a data container independent of class instances, something like an asset. They are very useful for memory saving because they are really small, lightweight and optimized. Let's see how we can create a scriptable object. First, let's create a folder. Then create a script. I will call it scriptable object example. And open it. Delete all functions. And instead of mono behavior, let's inherit from the scriptable object. This scriptable object will hold a reference to the power-up prefabs, so let's create an array of game objects. Next, let's create a function that will spawn one of the power-ups. It needs to be public and it takes one vector3 parameter for the spawn position. Let's get a random index. Then we can use the instantiate function. Spawn the power-up with that random index. Use spawn position and identity rotation. To create a scriptable object as an asset, we need to use the create asset menu attribute. Then we can use menu name, which will be scriptable object / power-up spawner. I will show you what is menu name in a second. First, let's add a default name to the object we will create. I will call it spawner. It doesn't matter, we will change it anyways. Go to Unity, right-click, go to Create, and now you should see scriptable object power-up spawner. That is the menu name we chose. So let's create one power-up spawner. As you can see, the default name is spawner. I will change it to power-up spawner basic. Now you should see the array of power-ups in the inspector. Here we will add prefabs that we need to spawn. Notice how it's easy to create another scriptable object that can have different prefabs. We need just one, so delete this one. Let's add some randomness to spawning. First, we need one integer spawn threshold. Then in the function, we can get a random number between 0 and 99. Remember, the last number is not included. After that, we check if the random chance number is greater than the spawn threshold. If that is true, then we need to instantiate a power-up. Let's go to Unity. We can set the spawn threshold to 80. So when we get a higher number, then we will spawn one of the power-ups. The chance is around 20%, precisely 19% since the maximum number is 99. So when to spawn power-ups? My idea is to spawn them when the player destroys meteors, but you can also easily spawn them if a certain enemy is destroyed. Let's see the meteor version. Go to the meteor script. In the death sequence, we need to call a function that will spawn power-ups. But first we need a scriptable object variable. I will call it power-up spawner. It's a good idea to check that the spawner is not null. Then we can call the function from the scriptable object. To the function, pass the position of the meteor. That's all we need to code. In Unity, select Meteor Prefabs. We need to set up a reference for the scriptable object. Drag the scriptable object to the empty field. To test spawning, we can select the scriptable object and drag any prefab into the array. I will use the green enemy prefab. I will also modify this level 1 to spawn more meteors. Just delete the enemy spawner. Then decrease spawn time to get more meteors. Of course, we need to select the win condition and modify the size of the array. Let's try it. When we destroy a meteor, the enemy can spawn. Great. In the next lectures, we create power-ups for the scriptable object spawner. See you there. Hi everyone, let's see how we can create collectibles and power-ups. In this lecture we create a power-up that will heal the player. First we need a power-up sprite. Use the yellow one. Increase the sort order to 4. Now let's add some components. Rigid body 2D. We don't need to change any option, we actually want gravity in this case. Now let's add the box collider 2D. It needs to be a trigger. Then we can adjust the size of the collider. This looks good. Let's create a layer for collectibles. We need to change the collision matrix. The collectibles layer needs to collide just with the player. Now we can create a new folder and script. I will call it Power Up Heal. add the script to the object. Let's open it. First, we need an integer variable heal amount. Then we can use the onTriggerEnter2D function. Because of the layer matrix, I know that this object will collide just with the player. But maybe you will need this power-up to collide with more objects. Then we can check if the object has the tag player. Here we will heal the player. We need to create a function in the player stats script. Let's open it. In the player stats, create a new public function. Call it add health. It takes one int parameter. Here we increase the health variable with heal amount. Then check if the current health is greater than the maximum health. If that is true, let's set the health to the maximum value. In this way, we can't have more health than the maximum value. We also need to update the health bar. Let's go back to the power-up script. Here we need to get the player stats component from the collision. Then call the add health function. After that, destroy the power-up object. This is all we need to code. Go back to Unity. Let's set heal amount. Then create a prefab. We can delete one from the scene. Now go to the scriptable object that we made in the previous lecture. This green enemy was just for testing. Let's replace it with the heal prefab we made. Then just make sure that meteors use the scriptable object. We did that in the previous lecture, but just in case you missed something. We can try it now. Let's damage the player. Then destroy meteors and the power-up should spawn. Great, everything works. See you in the next lecture. Hello everyone, in this lecture we create a shield power-up that will protect the player. First, let's use a shield sprite. Change the name and order in layer to 5. Notice one strange thing, the sprite shield is looking blocky and really bad. This sprite has some gradient and it causes this rendering issue. To fix it, let's select the shield sprite. We need to override some settings for Android and iOS. Enable override for iOS. Then change the format to this. Apply changes and you will see improvement. It looks much better. Now select Android settings and do the same thing. Don't forget to change the format. I will put a link to the list of supported formats and settings so you can find the best options for your game. Now let's drag the shield under the player prefab. Adjust the position a bit. Then we need to add Polygon Collider 2D. It needs to be a trigger. We can also edit the collider. Hold Ctrl and click on the lines to erase some vertices. Fewer vertices, better performance. This is fine, you can spend more time on this if you wish. Let's create a new layer for the shield. Call it shield. We need to go to the collision matrix. The shield needs to collide only with enemies and enemy projectiles. Then we can create a new script. I will call it shield. Add the script to the shield object and open it. Let's delete default functions. The shield will not have health, it will just count hits. So let's create a hits to destroy variable. I will set the value to 3. We need one public bool variable protection. When we enable the shield, make sure that we have 3 hits to destroy and that protection is true. Now create a function that will damage the shield. We decrease hits to destroy by 1. Then check if hits are less or equal to 0. Then set protection to false and deactivate the shield. We can also pick up shield power up while we already have a shield. Then let's just repair the shield. Set hits to destroy to the default value. Now we need the onTrigger enter 2D function. We know that the shield collides just with enemies and enemy projectiles, so we can try to get the enemy component. This line of code will try to get the component from the collision and store it in this variable. Then we need to destroy the enemy. We can use an insane amount of damage to make sure we destroy it. Then damage the shield. Else the shield collided with projectile. Then destroy the projectile and damage the shield. Then go to the player stats script. Here we need a reference to the shield. Then we need to prevent damage while the shield is active. So in the take damage function, if the shield protection is true, then return and don't execute the code below. In Unity, to test it, let's turn on protection. Then select the player and set up a reference for the shield. Let's try it. We have a shield that should protect us from 3 hits. 1, 2, 3. Great. Just a small digression, to make sure that bullets are visible in front of the shield, we can increase sort order. Now let's create another script. I will call it player shield activator. Select the player and add the script. Open it and delete default functions. We need a reference to the shield. Then let's create a public activate shield function. This function will be called when we pick up a power-up. Then we check if the shield is already active. If not, let's activate it. If it's active, let's repair the shield. Go back to Unity. Drag the shield into the empty field. Now select the shield and disable protection. Also disable the shield object. Select the player and apply overrides. Now we need to actually create a power-up object. Go to the prefabs folder and drag the heal power-up into the scene. We will create another prefab by adjusting this one. In that way we are saving time. First, let's change the sprite. Then we can remove the script and change the name. Now we can create a new prefab. The last thing we need to do is to create a new script. Call it Power Up Shield. Select the power up and add the script. Open it. We need the onTrigger enter 2D function. First, we make sure that the collision happened with the player. Through collision, we need to get to the shield activator. Then call the activate shield function. And then destroy the power-up object. Save it and go to Unity. Don't forget to override changes. We can delete the prefab from the scene. Then go to the scriptable object. We need to add a new prefab to the array. Choose the shield prefab. Let's try it. We need to get a shield power-up. Now we are protected for 3 hits. Great! In the next lecture we create UI icons so we can see the shield status. See you there! Hi everyone! In this lecture we create UI for the shield power-up. The UI will show the status of the shield. Let's expand canvas and right-click on the save area. We need to create an image. I will call it shield base icon. Let's change the source image. Use the icon base sprite. We can change the color. Then create another image. It needs to be a child object of the shield base icon. This will be shield icon. Change the sprite. Click on the Set Native Size button. Let's zoom out. Select the base icon object and change the anchor preset to the upper left corner. Now we can change the position. It needs to be below the health bar. Maybe the base is a bit too big, so let's change the width and height. This looks good. Now we can duplicate it. Move the duplicate to the right. Then repeat the process. We need 3 icons because the shield protection is 3 hits. Now select all base icons and disable them. Select the canvas prefab. In overrides, select shield icons and click on the apply selected button. Now in every level, this prefab will have shield icons. The next step is to go to the shield script. Here we need an array of game objects. I will call it shield base. This will be a reference to the shield icons. When we enable the shield, we can use the for loop to enable all icons. Then we need to create a function that will update icons when the shield takes damage. So let's create the update UI function. We will use the switch function. We check the hits to destroy variable. In case 0, that means that the hits to destroy variable is 0, then we need to disable all icons. At the end of the case, we use break to exit the switch function. In case 1, we need to enable the first icon and disable the others. In case 2, we enable 2 icons. In case 3, we enable all icons. In the damage function, let's make sure that the hits to destroy variable is 0 when the shield is destroyed. Also, in this function, we update UI. We also need to update UI in the repair function. Let's do one more thing. In the switch function, we can have a default case. This will happen when the variable we are checking, and that is hits to destroy, has a different value than any case. We don't have any other cases than 0, 1, 2, and 3, but we can put a debug log, so if that happens, something is wrong. Let's go back to Unity. We need to drag the icons into the array. Let's try it. We need shield power up. Now let's damage the shield so that we can see if the icons will update. As you can see, it works. We are not done. This is important. You need to update references in the template scene and other levels that we made for testing. Notice that if we use override for the player and go to another level, we don't have references. The prefabs can't remember references to other prefabs or objects. I repeat, at the end of the course, we will finish the template scene and then you can just duplicate it to create levels. After you updated your levels, let's go to the next lecture. Hi everyone, in this lecture we create a shooting power-up. As we pick it up, we get more shooting points. And when we take damage, we lose shooting points. First, let's create shooting points. Select the one that we already have and change the icon. Now we can duplicate it and rename it. Then adjust the position. Duplicate it again and change position. We need one more. This point will have some rotation, so change the name. Now let's duplicate points and place them on the right side of the spaceship. Remove the minus sign from the X value to make them symmetrical. For the last one, we also need to change rotation. Now let's go to the player shooting script. Let's make some changes and organize the script. I will just move this shooting point below the shooting interval. Then we can add a header attribute. Then let's create a header for upgrade points. Now we need references to 4 transform points. Then let's create a header for the last 2 points with rotation. We need 2 transform points. Then we need 1 integer variable upgrade level. Now we need to modify the shoot function. I will comment this line for a second. We will use the switch function. It will check the upgrade level variable. In case 0, we shoot only from 1 point. In case 1, we shoot from 2 points, left and right. Change the basic shoot point to the left cannon position. Then duplicate it and set the right cannon position. In case 2, we shoot from 3 points, from basic, left and right shooting points. In case 3, we shoot from 5 shooting points. Use the second left cannon and second right cannon positions. In case 4, we shoot from all shooting points, including the points with rotation. It's important to use rotation from the points instead of quaternion identity. We can also add the default case, which will do nothing. You can place a debug log if you wish. Notice that we use the instantiate function a lot. Creating and destroying a lot of objects, in this case bullets, can sometimes affect performance on mobile devices. So at the end of the course, see the optimization section and how we upgrade this. The next step is to create a public function that will increase the upgrade level variable. After we increase the level, we need to check if it's greater than 4, which is our maximum. Then just set it to 4. Go to Unity. Connect all shooting points with the script. Then we can apply overrides to the prefab. Now let's create a power-up. Use the health power-up prefab. We will adjust it and create a new one. Change the name, sprite, and remove the script. Let's create a new script. I will call it Power Up Shooting. Add the script to the prefab. Use the onTriggerEnter2D function. Check if the collision happened with the player. Then we need to get the player shooting component. Call the increase upgrade function. I will hardcode it to increase the upgrade by 1, but you can create a variable and pass it here if you want. Then destroy the power-up. Let's go back to Unity. Create a power-up prefab. delete one from the scene. Then we need to find our scriptable object. Add the prefab to the array. To make it easier to test, we can only spawn this power-up. Let's try it. As you can see, it works. Let's make the player loses one upgrade level when he takes damage. In the player shooting script, create the decrease upgrade function. Decrease the level by 1. And also make sure that it can go below 0. Go to the player stats script. We need a reference to the player shooting script. In the start, use the get component. Then when the player takes damage, let's call the decrease upgrade function. This is all we need to code. Let's try it. Pick up a power-up, then take damage, and the upgrade level should decrease. Nice. Have a nice day and see you in the next lecture.